Amen.
Amen. Okay, thank you so much, Sean. Girls, we are going to try to continue with our calculations in a moment. And there are several questions, and these questions we are going to go through them so that they give you different skills, because observations, we are going to be making slightly different observations as we go through them. So because they take a lot of time, we want to go into these questions as fast as we can. I'm first going to go to your notes, and then we pick up those questions and we attempt them. Hey, I thought that this document was already open. How to go back? I thought I had already opened this document, but it's taking long. Let me see why it is taking long. Let's see why it is taking long. Which one is that? Supposed to be another recent one. It's a good document. We had put it as a PDF, and I had opened it when I left here. I'm just wondering why it is not open. I'm so sorry about this delay. I don't know why it has taken place. Supposed to be opening, but that's why. Okay, that's it was. Okay. Okay, somebody is telling us a lot of what is happening at home. I hope you can mute the microphone so that we don't get home conversation.
Please mute the microphones.
Girls, can you hear me?
Yes.
Mute all of them. Oh, no, why it's
It's okay, the person is muted.
okay. Girls, can you see that document?
Yes.
That example?
No.
I don't think
It has not yet opened.
Okay. I'm asking, can you see that document that I've shared with everyone? It is your notes.
It has not yet opened.
file.
Not yet opened.
Hasn't.
Mr. Senjobe, first stop the share. First stop the share and then you share again. You'll see the document itself, and that's what you will share.
So is it okay now?
No.
Nah. Okay, I'll stop the share. I want to go to share. Then We go to that. I share. Are we okay now?
Yes.
Yes. Yes.
Okay, question 1. Kelly, read question 1. Kelly?
Yes, teacher.
Read.
A uniform meter rule is pivoted at its center G, and 3 masses are suspended at A, B, and C as shown below. Find the value of the weight W of the mass M placed at C so that the meter rule is balanced horizontally. Solution.
Okay.
Taking moments.
Okay, we are going to try to answer that question. Is that okay? Remember that in those notes, you are supposed to leave 10 lines for the working. Okay, so we have a uniform meter rule. I hope you can see the blackboard. Can you see the board?
Yes, teacher.
Yes, teacher.
Okay. I'm assuming that is our uniform meter rule. Now, a uniform meter rule starts at how many centimeters? 0 and ends at how many centimeters?
100.
100.
Okay. Now, what is the first mass? It is hung at what position A? Isn't it?
Yes.
Yes.
So I'm going to be using lines that the mass or a weight of how many newtons?
2
Newtons.
Suspended from that position. Then there is at position B. So this is at A. At B, there is another mass. That mass is hung at point B. Point B
1 Newton.
is 1
Newton.
Newton. Okay. Then what is the next part? We have centimeter mark.
The pivot at 50.
At that point, we have the pivot. So at the 50 centimeter mark, we have the pivot. I hope that is okay. That is our pivot. Which force we expect to act through the 50 centimeter mark? You have told us a uniform meter rule. Do we expect any force to act in that position?
No.
No. Center of gravity.
Center of gravity.
What force acts through the center of gravity?
Gravitational force.
What force acts through the center of gravity?
Gravitational.
Okay, when you move the point, there is a point C. What is that? Point C
W.
is there.
W.
There are distances. The distances are measured from the pivot. I'm going to place these distances here. What is the distance of A from the pivot that's been given?
30 centimeters.
Has it been given directly?
Yes.
What distance is that?
30
It is 30, isn't it?
Yes.
So I'll put that distance here. I'm sorry to change its position, but that distance is 30 centimeters. They have also given us this distance. What is that distance?
10 centimeters.
10 centimeters. All distances are measured from the pivot. Okay? So that's from that. Given us another distance. What distance is that? What distance is that? It is
40
called
centimeters.
40 centimeters. Now, so the thermometer rule, what we must understand what uniform means when they talk about a body. When they talk about a uniform body, what does that mean? It must be question.
The body whose center of gravity is at the middle. The
That
center
what?
the center of gravity of the body is at the middle.
That's true. The center of gravity is the middle. So if of gravity is in the what force acts in the middle?
Gravitational force.
And what force is that? Yes, it is gravitational force, but what force is that?
Weight.
For bodies, it has a particular name.
The resultant force.
Resultant
force.
The resultant force.
Resultant force.
Mr. Sari, help me find the graph of that force.
That is, we talked about uniform bodies in our introductory lessons. And then uniform body about it, we looked at the uniform laminar. And then in that center of gravity, we define the center of gravity. So, there's, within that definition, there's a force we talked about. So what is that force that always acts at the center of gravity of a uniform body or in the middle of the uniform body?
The resultant
force. No.
Teacher, the weight of that.
That we mentioned even in the previous lesson, every time they mention a uniform body in the question.
Weight of the meter ruler.
Thank you so much.
That's the weight of the meter ruler. Weight of the meter ruler acts at the center of gravity or the middle of the meter ruler because it is uniform. Are we together? So I'm asking you, are we going to ignore that force? Are we going to ignore the weight of the meter ruler? Because it is supposed to be there. It has the significance I want to point out in this lesson. Okay? And why we are ignoring it? It is quite important that we know why we are ignoring it in this question. So the weight of the meter ruler is acting exactly through the center of gravity, So can you give me a value for that weight of the meter ruler? I'll call it which weight should I give it?
Yes.
Okay.
Yes.
Weight P.
No, K is not visible. I call it P.
Yes.
Yes, P.
Okay. So P is equal to weight of the ruler. Now, let us see. What is the distance of P from the pivot? How far? Suppose we have to measure this distance, the distance of this force from the pivot.
0.
So it is 0. Is that okay? So it acts through the pivot. So what will be the moment of the weight?
Zero.
This may not be in your notes, but it's quite important. The moment of P about the pivot, how we find it? It is going to be P times what? P is the force. What's the distance of P from the pivot? Someone has mentioned that distance already.
P times 0.
P times 0. And therefore, what is the result? The result?
0.
0.
The result is 0. So if a force acts through the pivot, any force that acts through the pivot, what is its moment about the pivot?
Zero.
Any force, by the way, it does not have to be weight, but any force, as long as its line of action is through the pivot, its moment will always be zero. And what is the reason why it is zero? You are given the reason. Guys, I want to reduce this on your own. What is the reason? Because you have just given me the reason. The force is bad, but why is zero?
Resultant force.
What is zero?
Because it's the center of gravity.
Okay, it's not because it is balanced. Its distance from the pivot is zero.
Zero.
Is that clear, people?
Yes.
No.
All forces that
Please read.
their distance from the pivot is zero, their moment to the pivot is zero.
Want some? I don't want.
Okay, so we are noting that, please note that any force,
Yeah, I don't.
any force, guys are going to ask me whether I should write this or not. This time, any force that acts through the pivot
How am I going to write this crap?
is at zero distance from the pivot.
No?
Therefore,
Let the weight of the Richard rule be P. The distance
about the pivot.
zero.
Excuse me, teacher, I can't see the screen, your screen.
This weight times zero. Weight times distance. P times zero be zero.
So I've said the weight of the material is acting through the pivot.
It's your
So
story.
of P, the pivot P times zero. P is the distance from the pivot, which is zero. The result is a zero. And we are making a very important point. The force acts through the pivot for the turning point. And zero distance from the pivot, I'm abbreviating this. It is zero distance from the pivot. Therefore, its moment about the pivot is zero. That is basically the information that I want us to pick. So whenever we see anything that is acting through the pivot, we should not bother to find the moment. Automatically know the moment is a zero. I'm going to repeat that slowly. As long as a force acts through the pivot, its resultant moment will always be zero about the pivot. The reason is because the pivot is zero. I hope that point has been captured. And please remove this. I'm going because I'm going to remove it from the working. It is
Shall
something
cut
that
your
just
upper
need to
part
capture.
of screen. The top.
Upper part. The top part. I hope that is okay.
Yes, thank you, teacher.
If you have captured that, you are going to be working now. So I hope this has been captured. I hope everybody has understood and has captured this. Is it supposed to be written? It depends on you. But as long as you have captured it in your head. Okay, can we proceed and find the solution for W?
No.
Yes.
No. No, that no is going to delay us. Because you should be writing as we discuss or moving on or capturing. This by the way is a brief because if it is not captured in your notes, try to capture it. You should have checked through your notes. How to prepare as you prepare for this one, as you're coming for this one. I think this has staying in the for long enough, let us answer the question.
I guess you can move on.
You run.
Okay. Now, help me answer this question. This force here, we are going to ignore it because we know it is not going to have any effect as far as our moments are concerned because its moment is 0. So that's why I wanted to know that because it may have another effect in another type of question. Let us see. We are going to say that since at equilibrium, those are some of the symbols you can use for abbreviations. We are taking moments about G. I think the question is telling us to take moments about G. G was the center of it. And taking moments about G. So we are going to identify our anti-clockwise moments. Anti-clockwise moments are equal to clockwise moments. Again, those are abbreviations. So about G, what is the direction of this one? I think that's fine. Is that okay?
Yes.
What about
That's
this
the
one?
equal sign.
Yeah?
Is that after at equilibrium is equal to, I think, I don't know. I was wondering if it's an equal sign.
SM is equal to
Oh, the one, yeah.
equilibrium.
I'm saying the one above.
This is my answer, so the whole one will be equilibrium. Okay, write it to
Oh.
at equilibrium. Correct. Technology. At equilibrium, taking moments about G, and clockwise moment equal to clockwise moment. So I'm trying to identify the moments. Remember, when we are dealing with these forces, we deal with them individually. We ignore the rest and see. This will cause this turning. Similarly, this one will cause that turning. Now, what about this weight? It will cause that turning, isn't it? So
Yes.
this one will point that side. So which ones are the clockwise? Anti-clockwise, let's classify the anti-clockwise.
The A
And B. A and B.
B.
A and B, the anti-clockwise.
And B
So I write 2 times,
2 times 30.
2 times distance from the pivot,
30.
30.
30. I close that one. I add
1 times 10. 10.
Which is
I close.
Equal to
Then I go to the other side. 1 times
40.
W times 40. I'm not bothered in the units for centimeters. Can somebody give me the reason?
Because they are going to cancel out.
They are going to cancel out. Good. So what do we have here?
100.
60.
60.
Plus
10.
10.
is equal to
W.
40 W.
so 60 plus that gives us
70.
70 is equal to 40 W.
70 is equal to 40.
40 W. Next, what do I do?
Divide by
70
40.
by 40.
W
1.75.
Equal to 1
1
point.
point.
1.75.
1.75
1.75
Newton. Newton.
That's the answer to W. What the question required?
Yes. Find the
Was
value
supposed
of
to find
W. The value of the weight W.
That is how we answer that question. John,
Teacher, ask why did you include the 100 centimeters?
I was telling you distances measured from 0 and because they're talking about the uniform meter rule up to 100 centimeters. The uniform meter rule is 100 centimeters long, I simply take note of that this is the 0 point and this is the 100 point, because some questions may require that.
I think I've
Yeah,
understood.
it's necessary, but we would practice distance of 100 meters.
Just thank you. I've
Is
understood.
it right or is it not working?
Is it necessary to write all these statements before the working?
From
Okay,
and Grace. Okay.
I'm going to ask you something. Do you revise your notes? Our notes?
And Grace.
We revise our notes. Suppose we go to a book and it was empty of statements and we simply found writings. Would we understand those notes?
No.
Let me remove these things by the way. Some people, let's look at that. What is that? What does that mean? Without writings. What do they mean?
Then another one, how do you
So whoever doesn't want to write, please, this is what we mean. This is information, but it is very difficult to interpret. The best way to write your notes is to be able to refer to them every time by